Today for this theorem, the given is line GH is perpendicular to line HJ. So we're going to draw a right angle to show that these lines are perpendicular. The next given is that line KJ is perpendicular to line HJ. So we're going to draw another perpendicular, or a right angle to show that these lines are perpendicular. Our last given is that angle G is congruent to angle K. So we're going to show that they are congruent. And we have to prove that triangle GHJ is congruent to triangle KJH. So I'm going to start this out by saying that angle G is congruent to angle H. And the reason for that is it's given. My next step is going to be saying that angle GXH is congruent to angle KXJ. The reason for this is because vertical lines are congruent, or vertical angles, sorry. And then I'm going to put it on my chart, my little diagram, so I'll remember this. Okay, remember, we want to prove that triangle GHJ is congruent to triangle KJH. So my next step is going to be line KJ is congruent to line GH, and that line HX is congruent to line XJ. The reason for this is the isosceles triangle theorem. So we're going to put that down the chart. Line segment KJ is congruent to GH, and that HX is congruent to XJ. Okay. Now, so we have, remember, we have to prove that triangle GHJ is congruent to triangle KJH. Now we have one angle, three angles marked on here, a congruent side. So now I think we are on to our final step. We could say triangle GHJ is congruent to triangle KJH. And the reason for this is angle, side, angle. We can see here that angle K is congruent to angle G, which makes they're congruent. And we could see that line KJ is congruent to GH, so those lines are congruent. You could also see that angle GHX is perpendicular to J, and perpendicular lines are 90 degrees, and 90-degree angles, well, they're both 90-degree angles. So this is the proof for